science doesn't always change overnight. The Greeks theorized about the existence of atoms 2,000 years before we could actually detect one. The cover of Scientific American states in huge bold letters, "The proton problem. Could scientists be seeing signs of a whole new realm of physics?" For physicists, the measurement of the charge radius of the proton is fundamentally important to the understanding of our universe. When the first measurement came out in 2010, it was significantly different than the standard scientific thinking of the day allowed. They said there must be a mistake, that there must have been an error. So when a new measurement was done using heavier muonic particles which would allow for even greater accuracy, the results were even more shocking.
And so immediately I purchased the paper confirming the correct radius for the proton and that no errors were found in the earlier experiments. And so I took that number, I plugged it into my equation, and it outputted something remarkable. I was so excited to find that now my prediction is within one standard deviation of their data. And so evidence is supporting that actually our theoretical result might be the exact radius of the proton, and experiments are slowly creeping towards it, confirming the theory very strongly.
Standard thinking says that there are 4 fundamental forces in the universe: gravity, electromagnetism, the strong force, and the weak force. But the strong force and the weak force were theorized before we understood about black holes.
From my study of black holes and scaling laws of black hole structures in the universe, I found that the proton, or the nucleus of an atom, could act as a mini black hole. If you describe the little proton as a black hole, all of a sudden you calculate the gravitational force of 2 of these little black holes attracting each other, you get the exact force that we call the strong force that holds the nuclei together. Exactly. Not like approximately, but exactly. The strong force, that force that we actually invented out of nowhere because we didn't know how the protons held together, because they're positively charged, right? They're supposed to repel. So when we discovered that, we invented a force to force them to be together. And we said gravity is too weak to do the job. So we invented a new force. And since then, we can't get gravity and the strong force to like be nice to each other. And that's because we invented one of them. Since then, we've ran like supercomputers night and day, billions of dollars of investment in supercomputing power to try to find an analytical solution to the strong force, to LQCD. Zero solution has been found to this day. So maybe it's wrong, bro. Try that. Because these little protons are spinning very rapidly, when we move them away from each other, this very strong attractive force drops off very rapidly, which is what we call the Yukawa potential. Out of the geometry emerge an exact solution to the force necessary to keep the protons together. And out of that came out the spin of the protons. And from the spin, I'd extrapolated the range of the gravitational force of protons to one another. If they were mini black holes, that force would be completely eliminated. We wouldn't need the strong force because we would realize that it's actually the gravitational force acting at the quantum level. So I am able now to account for the strong force with the gravitational force and eliminate some of the largest complexities in quantum theory and reduce the number of fundamental forces in the universe. What really keeps me going, this amazing transformation I can see when a person realizes that they're connected to everything and that they matter in the universe. We live an imprint as we go in our daily life in the structure of space-time itself, that we're informing the structure of the vacuum, and so that nothing would be the same if we weren't there. We're actually participating in this incredible complex will works of nature, and that the communication of all the things in it is occurring through this imprint that we leave on the structure of space-time as we go along, as we interpret what we see and how we feel. And so we have a responsibility in our interpretation and our feelings and our behaviors in what we are feeding the universe.